Yeah, hi, welcome. So in this video, we are going to solve a problem using the two pointers technique. So first, let me run through the problem statement. So the problem here is we have been given a sorted array. So let us assume it has been sorted in ascending order, which is having a number of integers, and we have to find a pair of elements in the given array such that their sum is equals to value x. So for example, if we gonna see this example, we have an array 2, 3, 5, 8, 9, 10, and 11. We can see that this has been sorted in ascending order, and we need to create a program such that it will it will let us know whether there is a pair whose sum is equals to 17 or not. So here we have this array. So we are looking for a pair whose sum is 17. So we can see that if we add 8 and 9, the sum is 17. So basically, we have to the program should return a boolean such that it should say whether there is a pair whose value is equals to the expected value we go to program or not. Yeah. So this problem we're gonna be solving using the two pointers technique. So before solving using this technique, let us quickly run through this brute force approach so that it will justify why two pointers algorithms optimizes the code. So which is why time complexity reduction. So, in this brute force approach, basically we'll be looping through all the pairs of this array. So, we'll be creating two inner loops, and we'll be running through all the possible combinations of two pair in this array. So in the outer loop we'll be looping from 0 to the all the way to n is the length of this array, so we will be running from 0 to n minus 1, and in the loop we'll be running from the I plus 1 to the n minus 1. So basically we'll for 0 we'll be running from 0 1 to 0 n minus 1. For 1 we'll be running to 2 to n minus 1. Basically we are running through all the possible two pair combinations in this given array. So inside this for loops, nested for loops, we're gonna check whether the pair sum is equals to the expected sum or not. So if it is so, we'll be returning true. So after the end of these two for loops, we'll be returning false. So if there is any pair whose sum is equals to the given sum, it should have been returning true. So if it hasn't written anything, it means that there is no such pair. We'll be returning false. So this is the brute force approach. So we will be having two inner loops. So we can do one improvement in this brute force approach as well. This is that since we have an array which is of already sorted, right? So in this, when we are checking the condition in this inner loop, so if the sum of the pair exceeds the sum, we can break the inner loop and go through the next iteration in the outer loop. Since if sum of the pair greater exceeds the sum, then even if we increment the inner loop j, the sum will be greater since the array has already been sorted. So for that we can include this condition. So if array of sum of the pair is greater than the expected sum, we'll be breaking the inner loop and going to the next iteration in the outer loop. So this is what the brute force approach is. So in this brute force approach, we can see the time complexity. It will be like big of n square because we have a two inner loop, so we'll be looping twice, almost twice for every. Not twice. It will be like we'll be looping through like n square times almost, so it's an approximation. So that's why it is like big of n square, and space complexity is like constant. It is big of 1 because since we haven't created any data structures we are not filling any data structure, so that's why it is constant. The time complexity is a bit high. So now we're gonna check out the two pointer method. we're gonna see how this algorithm solves our time complexity problem and makes the code program efficient. So for that, first, what is the 2.0 technique? So we'll have two variables, point one pointing to the first element and other pointing to the last element. So we're gonna be adding the values to which these pointers have been pointed out. So if the sum of these two values is less than the expected sum, it means that we'll be shifting the left hand pointer to right hand side. If the sum of the pointers is like greater than the expected sum, then we'll be moving the right hand pointer to left hand side, such that we'll get closer to the expected value. Since if sum is like less than the expected value, it means that we have to increment a number. So since we can't increment the right side one, we'll be incremented the left side one, so we'll be incrementing I. So similarly, if sum is like greater than what we are expecting, then we'll be decrementing the j value. So this is how it gonna be. This algorithm gonna be performing. So as we can see here, so here we got an array. So expected sum is like 917, and first we have pointed two variables, one to first and one to last. The sum is like 13, so since it is less than the expected value, we're going to be incrementing I. And then still the sum of this is 14, still it is less than 17, we'll be incrementing I again. And then still 5 plus 11 16, still it is less than what we are expecting, so we'll be incrementing I again. So now it is like 8 plus 11. So it is expected is 19. The sum is 19, expected is 17. So since it is more, we'll be decrementing j. Yeah. So now it is like expected is 18. So since still it is sum is greater than expected, so we'll be decrementing j. So now I is 8, 9 is j is 9, 8 plus 9 is 17. So the sum value 17 matches with the expected value. So this is the pair. So we'll be returning a true. So this is how this computer program works. So now let us check the program. So here we can see I have created a method, so which takes input as two inputs. One is sum and one is array. So I have created two variables, which one is pointing to 0 first index and other is pointing to the last index of this array, which is n minus 1, where n is the length of this array. So then I'm going to loop it. The looping condition is like I less than j. So and inside this, if sum of the pair is like less than sum, expected sum, we'll be incrementing the left side operator. So if it is greater than sum, we'll be decrementing the right side operator. And if the sum matches the expected sum, we'll be returning true. And after this while loop, we'll be returning false. If suppose if there is any pair with the expected sum, it should be returning true in this loop itself. If it is not, then we'll return false. So this is how this program works. Basically, we'll be having two variables pointing to each side of the an array, and we'll be moving the pointers to left and right based on the sum, based on the given condition. So this is how this program works. In this case, the time complexity is big often, assuming that we got an array which is already sorted. So because each element, because in an iteration, each element of an this list will be visited only one side. So that's why it is like big of n. Suppose if we don't have a sorted array, we have to sort it. So for that sorting step might additionally take a big of n log n. So because since most of the even efficient algorithms take big of n log n, because most of this any average algorithm breaks the problem into sub problems, so which leads to this logarithm in this time complexity. So that's why it will be big of n log n, it max. So where n is the size of this list. And time complexity, it is constant. We haven't created any data structure, and we haven't filled that any data structure. So time complexity is constant. So yeah, so this is for this video. Thank you.